Imagine a world without numbers, no clocks, no prices, no measurements, just chaos. But somewhere in the shadows of human history, math quietly crept in, not with a bang, but with a whisper, and what it revealed was nothing short of magical. Long ago, ancient civilizations like the Romans had symbols for hundreds, thousands, and more, but they didn't have a way to write nothing. The idea of zero simply didn't exist. That is, until a brilliant Indian mathematician named Brahmagupta came along in the 7th century. He gave the world a symbol for zero, literally turning nothing into something. It was more than just a digit, it became the foundation of modern arithmetic. And then there's pi, that mysterious number starting with 3.14159 and spiraling off into infinity. It never repeats, never ends, and yet it hides everywhere, from the circles we draw to the orbits of planets, the ripples in water, and even the structure of DNA. Pi is infinite but essential, a riddle etched into the fabric of reality. What makes math even more extraordinary is its power to connect us across time and space. You could go to ancient Greece, modern Tokyo, or even another galaxy, and still to plus 2 would equal 4. Mathematics is the only truly universal language. It doesn't need translation. It's the silent code behind the universe. And if you look closely at nature, you'll see that it counts too. Look at the petals of a flower or the swirl of a seashell. Many follow a mysterious pattern known as the Fibonacci sequence: 0, 1, 1, 2, 3, 5, 8, 13. It's a simple idea: each number is the sum of the 2 before it, but this sequence is everywhere, from pine cones to hurricanes to the spiral arms of galaxies. But not all numbers play by the rules. Some prefer to be alone, like the prime numbers. These indivisible numbers 2, 3, 5, 7, and so on are the building blocks of all other numbers. They're essential to cryptography, keeping our digital lives safe. Without them, your private messages and online transactions wouldn't be secure. Even the idea of negative numbers was once controversial. For ancient mathematicians, it seemed absurd. How can you have less than nothing? For centuries, they rejected negative numbers entirely. But over time, math embraced the concept, and with it came balance, symmetry, and a whole new world of equations. One of math's greatest mysteries was scribbled in the margin of a book by Pierre de Fermat in the 1600s. He claimed that there were no whole number solutions for the equation n plus b equals c when n is greater than 2. He said he had a truly marvelous